All right, so the first thing I wanted to do before I get too deep into things is I wanted to talk a little bit about some examples of parallel inheritance hierarchies because this came up last week. And I said I would find some examples of this so that there we go. Some examples of this to kind of bring the point home. So I have an easier example here and I have a more complicated example on the next tab. So parallel inheritance hierarchies, to just give you the brief overview again, is when you have two different inheritance hierarchies and whenever you add a class to one of the hierarchies, they're coupled such that you also have to add another class to the other inheritance hierarchy. And you can kind of see this if we have two big superclasses, dinosaur and egg. And then we want to make a new kind of dinosaur, the velociraptor, means that we also need to make another class, velociraptor egg, because the actual egg is going to have some differences between other eggs as well. Maybe it's a slightly different size, has a slightly different chemical composition. Who knows exactly what's embedded in these classes? But the fact that we have what came first, the dinosaur or the egg, and then adding a new dinosaur means that you need to add a new egg, or adding a new egg means that you need to add a new dinosaur. They're coupled in such a way that it's really difficult to break that coupling. And we don't really like this. We want to be able to find a way to only make one new thing when there is one new thing and not have to split off and try to make a bunch of new classes in a bunch of different inheritance hierarchies. So we talked about there being a couple main ways to deal with this. So one of them is you're going to design a class that has implementation details for both the dinosaur and the egg in a single class. That way, if you make a new kind of dinosaur, the egg is embedded within that same class. Another is to reduce both of the hierarchies into a single class, such that you have one of the hierarchies refer to the other hierarchy. And that way you don't need to make two different, like if you use composition within your hierarchy, meaning that, all right, you have a dinosaur class, and in the dinosaur class, you have a field that is an egg class. So when you make a new dinosaur, all you're changing is the field associated with that object. You don't need to make a new kind of object. You just refer to the other inheritance hierarchy of some kind. The more complicated example, did anyone have any questions on the simpler example? As I've referred to, or I guess, how do I want to state it? I've hinted at the size of code and how things kind of explode as you get more and more code. I also wanted to find something that would show you kind of how this code smell would look in a larger code environment. If you just have, the eggs and the dinosaurs, it's pretty easy to see the attached hierarchies here. So here we have engineers and milestones. So we have an engineer class that describes a programmer, and you have a milestone class that describes some level of achievement for an engineer, but it's not built directly into the engineer class. It's a separate class that can have additional OO principles applied to it. So different engineers have different milestones. Each engineer has a specified milestone. Every time you add a new engineer to the engineer inheritance, you have to introduce a new milestone into the milestone hierarchy for that engineer to have that milestone. So here's what some of the code would look like. We have an engineer interface and a milestone interface showing that when we go to, let me blow this up a little bit so people can see it better. If you want to make a new engineer subclass, we need to be able to get the type, set the type, get the salary, set the salary, get a milestone and set the milestone. And then in the milestone interface to make a new milestone, you need some way for it to work on the milestone and some target for the milestone. So we can have a computer engineer. This is a subtype of the engineer superclass. So there's a type of engineer, there's a computer engineer, there's a salary associated with a computer engineer, a particular milestone, and then you can set the type, set the salary, set the milestone, get the type, get the salary, get the milestone, and a toString for it. Here's a computer milestone that is for computer engineers. So working on this builds a billing microservice. And the target has to be finished in 14 paid days. I don't actually know what PD stands for in this case. Anyone can stand for whatever you want. Some unit of measurement, 14 of some unit of measurement. And then a toString to print it out. There's also a civil engineer, not a computer engineer, but a civil engineer that has a type and a salary and a milestone. These paid days. And then there is a civil milestone where work now creates twin towers and the target has to be completed in 2 years. So they're slightly different. There's a class manager. And you can now see that if we were to generate a new type of engineer or a new type of milestone, they're kind of paired like this. So again, we have to make 2 different classes whenever we want to add one kind of object, which is the smell. That's why this is not good. Questions on this? Is this enough of an example to see what the issue is and how this plays out? Obviously, I want you to be able to actually go get some experience with this as well. I'm still working on the lab setups for the course over the next couple of days. I think we're gonna have that ironed out. So we'll actually be able to assign labs, but the important labs don't even start until we start with design patterns. So I can give you a bit of a sense of where we're headed in the course. Today, we should be able to finish the code smells. And then starting tomorrow, we're going to start learning about UML diagrams and being able to read class diagrams. So if you go to that refactoring guru site that has this entire list of code smells, the entire list of design patterns, the entire list of refactoring methods, basically the ways that we can refactor our code to eliminate some of the issues that we discussed in the code smells and the design patterns. All of that is going to use class diagrams. And we want to make sure that you can read the class diagrams and understand what they're trying to tell you so that you can better understand the code smells and especially the design patterns once we get to them. So I'm anticipating doing that for the rest of this week. And then starting next week, we're going to start in on groups of design patterns. I want to be able to get through about 3 of them, 3 different groups. And for each associated group, there's going to be a small project that you will implement that set of design patterns for to make some kind of application that is scalable and utilizes those sets of design patterns. So that's what's coming. And in the meantime, as we're learning them, there are going to be some smaller labs that you'll be able to work on. So kind of splitting out between labs and projects. The labs will help you learn the design pattern. The project will pair related design patterns and allow you to create a larger application that utilizes these related design patterns. So that's the theory of what we're doing and how we're going to go about it for the rest of the quarter, because it's hard to fill 10 weeks with just design patterns because they're monotonous. There's so many of them. I want to kind of break it up a little bit and motivate them a little bit more. Okay, let's finish off these code smells. There are lots of them. Is data class the last one we covered? Did we do any after that? I don't think we got to lazy class. Did we do data class? We did duplicate code. Right? Which was the last one we did? Duplicate code?
I feel like we ended on looking at vector, but I don't remember for sure.
Yeah, I think we did go look at refactoring guru for duplicate code. Does that sound right? Is that what's in other people's notes? I have the memory of a goldfish, a stereotypical goldfish. I swim around for 30 seconds. I forget where I came from.
Yep.
So sometimes I rely on students. What's the last thing we did? Because I don't remember. All right. The next dispensable is a data class. So the issue for a data class is you've created this class structure but it only has fields, it doesn't really have methods. The only methods that you might have are those that access or modify the fields. You don't have any real behavior associated with the class. And the entire purpose of a class and an object is to have both state and behavior. If you have just state, then there's some things we can do about it in order to try to reduce the size of the code, because we shouldn't have a class that's dedicated only to state. So you can ask yourself the following question: what code uses the data that's embedded in this data object or this data class? We could move the code, move the state of this into the class that utilizes this behavior, and then end up being able to delete this class. One thing that may happen is this changes the encapsulation of the object. We know off the top of my head when I say encapsulation what that means. So objects should know about their internal state and only their internal state. And if some other object wants to know about their internal state, they need to utilize the getters and setters of the state of the object to be able to interact with it. And they can only interact with it in ways that public facing methods do. There can also be private helper methods that are internal to the object that aren't accessible from outside of that object. So whenever you're using the keyword private, you're keeping that information within that class. So if you move additional fields from one class into another class, they may change the associated desired privacy of each of those fields or each of the associated getters and setters, because they're now embedded inside of a different object. So if instead you wanted a different level of privacy from a different object perspective, you may need to think about and change that. So make sure that you review the encapsulation, the public and private of each of the fields that you're moving. If you're removing setters, for instance, that may indeed change things. It was easy enough if it was embedded within an object, but if it's merged into a new object and this object now has a setter that subtly affects other aspects of that object or the other internal state of that object, that may be bad. So you may want to refactor or even remove some of the setters as you do this to prevent unwanted access to the new object. As you do this, you get better understanding and organization of your code because you just have fewer classes. And each class will, again, do what it's supposed to do. You don't have the purpose of one object broken into multiple classes, some that has the state, some that has some of the behavior. That can be really disorganized to try to understand, where is this in my code? Oh, it's split amongst 2 or 3 different classes. I need to keep in my head when I'm thinking about how does this grand scheme project work, that if I care about this part of this idea, it's in this class, but this part of this idea is in this class. If you find yourself doing that a lot, that's due to code disorganization. There could be some duplicate code. If some of these fields are kind of in 2 places at once, that can be bad, but it can help you to isolate that if you go to refactor it and you realize, oh, this is actually already embedded inside of this object. I don't need 2 copies of it. Questions on the data class? So classes should always have state and behavior. State and behavior. If they just have state, there needs to be a reason for that state to just be state. It can't just be that the behavior is in another object. You might want to consider combining them. A lazy class is a class that doesn't do very much. It just kind of sits there as waiting to be accessed or waiting for some very special case to trigger the need for this class. It was designed to be fully functional, but maybe after some refactoring, it doesn't do very much. Or maybe it was assigned as an optional feature in a particular sprint. We never got around to it and it became the lowest priority, so it got cut from the final project. But you have this class sitting around that doesn't do very much, that is not actually necessary. So can also happen because there's future work that never got done. Some fixes for this. You can move the class into another one that does nearly the same work, if such a class exists. If it's part of an inheritance hierarchy, you can collapse the inheritance hierarchy because it's just not needed. You can outright delete it if it is not needed at all. But some of the refactoring parts of this may involve moving the class or collapsing an inheritance hierarchy. If you do this, your code is smaller. Smaller code is better code if it does the same thing. Maintenance, you don't need to worry about any change that I make to some other class affecting this class because you've merged it into another class or deleted it. Kind of a pretty straightforward code smell, but something that's in a larger project often worth just going through and saying, what do these classes do? When are they triggered? When do we instantiate them? If they're instantiated, when do we call the methods of these? If you can't think of reasons that this particular class exists, then maybe it's time to kick it to the bucket. Next dispensable is called dead code. This isn't an entire class, but it might be part of a class that is no longer used. So a particular field method, if it's inside of a driver class, it could even be a variable or a parameter to a method that is no longer, if we're just not using it anymore because of a particular refactor. You refactored the code, but you didn't necessarily refactor the call to that code. So you have more parameters than you need, an extra variable somewhere that's not used in any calculation that can increase the complexity of your code. It can increase the running time of your code, usually not too terribly, but it's just more complicated code than necessary. So it could just be obsolete, meaning that you did some refactor and changed how things work, and you don't need every aspect that you did before. You could also have talked to your client and your client says, oh, I don't actually need that functionality, you can get rid of it. Or instead of implementing it this way, why don't we look at implementing it this way so that it's easier for my end? And then you go do a refactor of your code to make it easier for your client, and you find that you have excess stuff in your code that you still want, but this extra stuff isn't used anymore. As an example, you have a conditional. Maybe there are, you have an if, else if, else if, else. And one of those else ifs just can't be reached anymore. There's no way to trigger that else if clause. If you use an IDE that looks for this, then you may find some kind of underline or something that says this code is unreachable. Maybe you should consider whenever you see something like unreachable code, you don't necessarily want to jump to the conclusion that it's not necessary. Maybe there's a logic error somewhere in your code where this code should be reachable and it's not. But that will at least identify a potential issue for you to look into the reasoning for. So you want to delete any unused code. And if it is, it's usually the answer to this particular code smell. But if you do find the issue with something like unreachable code, you'll want to make sure you ask yourself the question, should this be reachable or is it useless? Questions on dead code? All right, the next one is speculative generality, which is kind of a mouthful. So you make some code, and this code is very conditional, meaning that it's only going to be called in the very isolated circumstances or for a feature that hasn't been implemented yet, or in fact, a feature that has now been cut from the final product. So you have kind of just in case code sitting around that needs to now be refactored because things have changed since you went to go create this code. What can we do about it? We can remove any code that is not used. It's pretty straightforward here. But you may need to refactor. It's not just as simple as identifying that code and deleting it. Before you go delete any code, you're gonna wanna think about the following kinds of things. Is deleting this code going to change other code that is used in some capacity? Are there any dependencies here? If there are, you may need to refactor that dependency. So it's not always bad to have these just in case features. If it's a framework, functionality could be for the end users and not just the framework itself. So it can look like there's some just in case code here that's actually being used by the end users. If you just delete code like this, you may end up breaking unit tests that depend on that code. So it's always also worth thinking about, if I'm gonna just delete code, going back through any unit tests for that class and say, is this code used by any unit test? Especially if those unit tests are for continuous integration. We talked about this concept of building tests into whether or not code changes are accepted or rejected. You don't want tests to fail just because you deleted some unneeded code and now tests fail and now nobody can change any code in your code repository because the tests have no way of succeeding. Questions on speculative generality or any of the associated issues? That does it for the dispensables. We only have one big type left, and those are couplers. So to remind you, couplers again are when we have multiple classes that are interdependent on each other. That shouldn't necessarily be. If there's an equivalent way to do all of this logic without these classes needing to access each other's materials, we just kind of break them apart. That helps. So feature envy is a concept where we have a method in one class that needs access to another class's data more than its own. Think of this like, has anyone been in a group where someone else, or you've done all the work, for instance, and someone else just kind of been dead weight? I think most people have probably experienced something like that. From the other person's perspective, they're relying more on you than on themselves to be able to finish the product or finish the project. So whenever you make a class, you should make sure that most of the time that class is used, it's looking at its own internal state, or the behavior associated with it is changing its own internal state or referencing its own internal state. If more of the code in a class is looking at another class's behavior or another class's internal state to make its decisions, that is not great and means that it can probably be combined in some sense. Or some of the functionality in one of the classes should actually be in the other class because it's querying so much about that class's state that you want to really focus on the current object. So if you move fields as part of a refactoring, then you need to change wherever those fields are being accessed. If you have some reason design-wise that a particular field belongs in class B instead of class A, but all of class A's methods access that field, then you're going to be calling the functionality of class B a lot in class A, which again is perfectly okay in the short term, but as you start to refactor, you might realize that more changes need to happen to your code. So whenever you move fields, ask yourself how many methods utilize that field. Where are those methods located? Are they in the class that you moved the field from or the class that you moved the field to? If it's more frequently what you moved the field to, then maybe some of those methods should also move. Usually it's kind of going to be an all or nothing thing. You either move all the methods or you don't move all the methods. You're not gonna move some of them usually. But there may be some reasons for them to stay in the class that they feel moved from. In general, if you have methods that utilize some fields of some class, they should be in the class where most of those fields are, which minimizes the amount of communication that needs to happen between objects. But it's not straightforward to do this. You may create some additional issues as you do this as well. It's just something that, again, is worth considering as part of that refactoring process. So some of the benefits you get: less code duplication. If you have all of your data handling code in a central location, instead of trying to get it from A, which needs to get it from B, it'll just get it straight from B. You have better code organization. Whenever you have some behavior, some methods, and inside of those methods is something that queries another class, you have to then open up two classes to understand all of the functionality embedded in this class, because there's communication between the different classes more. So if you minimize that, then you have better code organization, meaning that most of the time, whatever is being referred to in those methods are local to that object. You can see within the state of that object what you're referring to without needing to refer to another object. So we call that feature envy. The next coupler is called inappropriate intimacy. So one class needs access to the private fields and methods of another object in order to do what it's supposed to do. Which means that design-wise, you're thinking, all right, the easy solution to this is just to make those fields or methods in this other object public so that I can access it from this other field or this other class. Or I need to write getters and setters for all of these fields so that this other object can have easy access to them. The issue, of course, is that this massively violates encapsulation. You should not be changing anything that should be private to one class to public for any reason. And you should not be writing setters for fields that should not be changed from outside their scope. So classes need to know as little about each other as possible. This maximizes your security. As soon as you introduce this, as soon as you make something public or write a setter for something that shouldn't have a setter, you have a massive security vulnerability. Someone can change that from outside the scope of that class, and there's nothing that says that, yes, this other class needs to make that change, but nobody else should be able to make that change. Nothing like that really exists unless you're using the protected keyword if that other class happens to be within the same package. But in general, everything should stay very, 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 very private and related to that class only. Sometimes some of these things may need to be moved, and that's okay. If class A really needs to know something about class B, maybe the appropriate location for that information shouldn't be in class B, it should be in class A. So if you move it, that's okay. But note that again, if B needs access, class B needs access to those fields or methods, you might still end up with the same issue. This is where some of the design patterns come in, where you can give certain classes access, or rather the class, for instance, produces a snapshot of its state and then shares that. Think of it like kind of like a camera where you take a picture of yourself and then send it. There's nothing that says that you can be modified by sending a picture of yourself to somebody else. They can't modify that in some capacity. They can modify the image, but that doesn't modify the internal state of you, the person. So taking things like snapshots of objects are fairly frequently used in like the memento pattern, for instance. So you can also ask yourself the following question: do these classes associate between each other? And by that, we mean bidirectionally. That means does class A communicate with class B? Does class B communicate with class A? If so, we don't want this kind of bidirectional communication between classes. There should always be unidirectional association. There should always be a request from one object to another. What is your state? Boom, returned. Or I want to change this from this to this. There shouldn't be this long communication between different objects. It should always be either a command or a request that's being made between one object and another object. If we get rid of this inappropriate intimacy between our classes, we have better code organization, simplifies support, and one that's not here, removes security vulnerabilities from your application. We're almost done. We only have a couple more. Couple or more. So, incomplete library class occurs when you're going to use a library, but the library doesn't do everything that you need it to do. Has anyone experienced this before in any project where you want to utilize some library code and it does some of what you want, but not all of what you want? Yeah, or it just gives you a bunch of stuff you don't need. Luckily, that you can ignore, but it's really hard if you don't get all of the functionality that you need out of a library. So you have two options, really. You can rewrite the entire library from scratch, which is, yeah, you could do that to include your functionality, but in the same way that like a primitive wrapper class, like the integer class wraps around an int, you can wrap your own code around the library. So here again, I couldn't quite easily come up with a good image or a good code example for this, so I linked to Refactoring Guru. If you have a few small methods that you want to wrap around the library so that you get a little bit of additional functionality out of the library, you can introduce a foreign method. So I'll quickly show you what that looks like. I exit this. There we go. So here's introduce foreign method. So you can imagine that this report class right here can send a report. It takes a date the next day, and then it generates a new date that is the next day, and then sends a report on that date. So we don't quite have this method that can send it at a particular new start time. This is just hard coding, that it's always sent the next day. Here we have the ability, if we expand this one, expand it, contract. Sometimes it's kind of buggy at times. There we go. So note that send report still has the same material, but you now write a bit of a wrapper thing around that. So next day still has the same next day, but we now wrap this around. We're adding a method to the client class, passing an object of the utility class. So we pass a next day, and then we can get a new date out of that based off of that next day. And then use that in our send report. And of course, it's back at the start. I want to, if you have large scale changes, so you can wrap very small things very easily up like that. But for large scale changes, you can introduce a local extension. So this looks something like this. And again, I wish I'd gone over the UML stuff, because being able to read things like arrows between classes like this show you exactly how these classes are related to each other. And that's super useful for being able to visually represent a program and how classes interact. So utility class doesn't contain some of the methods that you need. You can't add the methods to the class because you don't have access to the source code. So we'll create a new class that contains all of the methods of the old class, and you make it either the child or the parent, a wrapper around it, of the new utility class. So you're just going to put all of the old information in an object as a component of the new object that you're going to wrap around it that has all of the other information that you need. If that makes sense. So in the problem, we have a client class with next day, and great, we need some way to better specify this. So we're going to create our own inheritance hierarchy and make this MF date a subclass of date so that we can further specify information and make it more general than this method expects it to be. Does that work? I don't know if I explained that particularly well. I'll come up with a better example for it. But the basic idea is that it's very similar to an int, where when the primitive int doesn't do what you need it to do, we can wrap something around it that has the additional functionality. So let's say the integer class doesn't exist. It just doesn't exist. We want to be able to convert an int to a string. We want that functionality. If we can imagine the primitive int being a class, we're going to create a wrapper class around this concept of an int that also has the extra information that we want. So this also has the toString behavior that we actually want. So this exists. We're just going to wrap around some additional functionality that doesn't modify this at all. And if this is a class, it will have completely unchanged public methods that are how you can interact with the object. But now you can also access this object's fields and behavior that contains this behavior inside of it. So it doesn't do everything that you need. You wrap around the behavior that you need around that object. Does that work better? I'll come up with another example for next time. So you can introduce some content to an existing library. All right, this is, I think, the second to last one. Message chains. We have a long sequence of method calls. Have we seen this before? Java's especially very known for this. We have, this dot, that dot, another thing, dot, yet another thing, dot. You can get a really long line of methods that all call each other. And then the return from one method is fed as a parameter into the next method, which you get this really long chain of calls. So we get a nice long sequence of method calls, each of which needs to be passed to another object as an argument. So some other object utilizes each one of those return values from that long sequence of method calls, and that's the parameter list for the next call or the next creation of an object. So the client says, I need an object, and that object needs another object, and that object needs yet another object. Does the smell make sense? The issue, the problem here? So we can hide delegate. We want to do this. And again, I need to exit this. So the problem, we have the client class getting object B from a field or method of object A, then the client calls a method of object B. So we need to get object B, but we need to call a fielder method of object A in order to create object B. Then the client is going to, after creating object B, utilize that for some other purpose. So we have this kind of interdependency between these two classes. The client class needs both of them, but they need each other to be able to construct each other, or at least one of them needs the other. So we need to first create a department before we can create a person who is in that department. If we need both a person and a department in the client class, then we need to create a department. That department needs to create a person so the client class can reference that person. Kind of gross. Instead, the solution is we have a method in class A delegating the call to object B. The client, instead of needing to know about two different classes at the same time, only needs to know about the person because the person knows which department they belong to. So we do delegation rather than trying to keep track of everything at the same time. So if you care about this, you can look it up and read more about why, etc. Again, this is a really good resource for this. So we can reduce dependency because that's important. Whenever you have a class that needs access to a bunch of other classes, more bugs can arise. If, for instance, you want to create a department, but the department doesn't have the person yet, then you can end up with null pointer exceptions. You can end up with, there are lots of other ways the code can break. And of course, reduces code bloat because instead of relying on two other classes, you're relying on one other class. Always a good thing. All of this stems from the fact that OO coding is so complicated. We can have a middleman coupler. If you're too zealous with message chains, you get a long message chain where from the base class, you need to create an object A, which delegates creation of object B, which delegates creation of object C, which delegates object D, etc., and a really long message chain. So in this way, you end up with classes whose sole purpose of existence is to delegate the work to another class, which seems silly. I like thinking about this like you hire an employee who knows absolutely nothing, except they exist to forward all issues they get to someone who actually knows how to solve the problem. They're a completely useless employee. You could just bypass the middleman and go directly to the source, someone who knows exactly how to solve the problem. It's a useless middle ground for no purpose. So we can go through a process to remove a middleman. We need to first be able to identify that its sole purpose is just to delegate its work. And you get less bulky code. You may find that there is a time when this is important. If the middle class is there to avoid particular dependencies within, like for instance, if B is a middleman between A and C, and A should not be able to communicate with C at all. Like there's a place in the hierarchy where just like these two cannot speak to each other for any reason. Then B might have a purpose as a middleman between that. A sends to B sends to C sends the message back to B sends the message back to A. So if you have that kind of dependency in your code where A should not talk to C, then a middleman who has no other purpose might be useful. Proxy and decorator are two design patterns that have a middleman on purpose. And when we talk about, we will at least talk about decorator. I don't know if we will talk about proxy, but sometimes there's a reason to have that middleman. And we can come back to this as we talk about those design patterns. Let's quickly look at this removing of the middleman. So class has too many methods that simply delegate to other objects. So we have a client class, we have a person, and the person's only task is to get its manager, which means we need to figure out which department they're in, so we talk to the associated manager, but a person doesn't actually do anything. So the solution is to go right back to where we saw before, it's the exact opposite way, where now the client class can talk to both the person and the department. So we see this a lot, that we have depending on the problem, we can go from A to B or B to A, and they each have their own pros and cons. So you delete the methods and force the client to call and the methods within the objects directly. And again, there are times when this is good and times when this is bad. And it just depends. So I kind of want to spend just the last couple minutes of class summarizing the code smells. So the entire purpose of all of this, and I know that this was a big just data dump in a way that I'm not really happy with. But at the same time, I don't know if there's a better way to go over 30 different code smells than just kind of to say, these are all issues that you should be familiar with. You're probably going to get the most out of this, not by being presented, because you haven't. And this is one of my main issues with this class in general, is you don't yet have the experience where I can talk about it at a high level. And to get you that experience is more than a quarter's worth of work. Like you need a lab for each one of these code smells to be able to identify, oh, this is why this particular code smell is here, and this is what I should do about it. But we don't have time to do all of that, and you don't have the experience to be able to go through it at a high level. Not really something I have control over as the instructor of the course. I'm just told, teach all of this material, and there's no real nice, easy way to talk about code smells. My recommendation is, once we talk about UML diagrams, spend a few hours just on Refactoring Guru, looking through some of these and seeing if you can come up with some examples and try to understand why that is, or when it might come up in your own code. And when you take future courses like software engineering or advanced software engineering at the master's level, higher up courses in computer science, the goal is to be able to notice something is off about my code. Even if you can't quite pin exactly what it is, if you say there has to be a better way to do this, and something just sparks in your brain that says, oh, this is a shotgun surgery issue, or this is something related to two classes that are too tightly coupled together, then you can go back to that resource and much more quickly find out what the code smell is, what's causing your code to have that issue, and then have the tools to be able to fix it. I don't expect you to be able to memorize everything from this set of slides and be able to apply them at the appropriate times, but just getting that sense that something is off can do wonders for your eventual code. I guess we can talk about this. We'll summarize this at the start of next class before we dive into UML. I know this was boring. I apologize for that. But hopefully you got something out of it. See you all tomorrow.
See you tomorrow, so.
Thank you. See you tomorrow.
See you tomorrow.